Okay, good morning. So today we're looking at the Metro Central Education District, the September Common Paper 2021. Okay. So in this video we're going to look at question 1 and question 2, the statistical part of the paper, statistics questions on the paper. So let's head straight into it. So in question 1 we are told the approximate electricity charge in a range of 27 flats in a particular block of flats in a given month were recorded as follows. You are given table 1, so that is what we call the raw score or the raw data, and we are given table 2, which is your distributive table, the distributive data. Okay. In question 1.1.1 says complete the distribution table. Okay, so in other words, you must fill in the frequency column. Okay, so by filling in the frequency column, we know that whatever value is recorded here will be transferred there. Then we take the cumulative frequency and we add the next frequency to get the cumulative, second cumulative frequency, and so on. Okay, cumulative means to say to add on. Okay, retain and add on. Okay, so if this value, the first value is transferred, this has to be 1. 1 plus a number is 7, so the number has to be 6. 7 plus a number is equal to 15, so the number has to be 8. 15 plus a number is 24. Should be 9. 24 plus a number is 27, which is 3. Or I could have said 27 minus 4 is 3. 24 minus 15 is 9, and so on. Okay. So either way, you will get the marks there for that question. Okay. In the next question, in question 1.2, we are asked to write down the modal class. Now the modal class is the class that has the most entries in, or the most, most entries in. So in this case, the one that has the most entries in is that category from 800. X is greater or equal to 800 but less than 900. So what is the modal class? The modal class is X is greater than or equal to 800 but less than 900. Okay. The next question says draw an ogive graph cumulative frequency to represent the above information. Now this question was poorly answered from the students who I've marked. When we draw cumulative frequency, okay, we use the endpoint of the class interval and we use our cumulative frequency. So the point to be plotted is going to be 601, then 707, okay, then 815, 924, then 1027. Okay. Many students, what they did was they used the midpoint of the class interval to draw the cumulative frequency, which lost them a mark, and they used the ruler to draw the graph. Okay. The cumulative frequency polygon is a smooth curve. Okay, so those are the points we will be plotting. I'm just going to move this up so that we can have our points in focus here. Let's just take this off. So there wasn't values given on the axis. Okay, so we needed to give our to plot our own increments of our values here. We know this will be your cumulative frequency here. As you can see, the frequency, your cumulative frequency's maximum value is 27. Okay, so if I count 2, 4, 6, 8, 10, 12, 14, 16, 18, it won't be enough. However, if I go 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay. But if you had gone in 4s, units of 4s, there's no problem with that as well. Okay. Then on our interval, we the smallest value is 500. So if we break it by here, we start there, 500, 600, 700, 800, 900, 1000. So there's so much space left, so what we do is we just make it a bit bigger. So it's 500, 600, 700, 800, 900 and 1000. We always try and make, this is your interval inner end. Okay, we always try and make it as big as possible. So the bigger the graph is, the more accurate would your values be. Okay. So again, when we plot 601. So we go 601 is approximately there. Then we go with 707. So 706, 7 is just above that. 815, so it's on here, so 815. Okay. 924, so we go 924. Okay. Then we get 1027. 1027 is there. So what do you see now? We can connect the dots freehand, not with a ruler. If you're going to use a ruler, you should use a mark. So we connect freehand these dots. Okay. And you see that the starting point, which was 500, okay, the starting point, which is 500, that is where we connect the ogive graph to. So 500, which is here 500, so we connect it. Okay. If we don't put this in here, you should also do a cluster mark. Okay. Normally there's a whole mark allocated for that, for grounding the graph properly. So don't mess up on that grounding. Okay. The next question. Let's get the next question. Okay, in your next question, we are asked, use your ogive graph, which your cumulative frequency here, polygon, to determine the median cost in a range of 27 of the 27 flats of the given month. So your median is basically your middle number of sorted data. As you can see, the data at this point is sorted. Okay. So there are 27 values. 27 divided. There's 27 flats. So we go with 27 divided by 2. Will give you. So firstly we go 27 divided by 2, which gives you 26 is 13.5. So that's 13.5%. Otherwise, I know some people that to work out the median, they say n plus 1 over 2, which would give you then an answer of 14. So either at 13.5 or 14, you take your reading. Okay? So that's 12, 13, 14, 15. So 13.5 is midway between that. So with a ruler, I drew the dotted line there across until I hit the graph. Okay. Once I hit the graph, I turn the ruler vertical. So at first I draw a horizontal line, then I draw a vertical line. A line perpendicular to your x-axis or parallel to your y-axis. Then I take the reading at this point as my median. Okay, and by the looks of it, if that is 750, I would say that is about 780. So your median is approximately 780. Okay, now everybody's graph is not going to be the same. Okay, so you could have had a value closer to 750 or 760. I think the memo was at 760. But of course you won't get a value less than 700 or a value more than 800. So a value within a certain range there, as you can see, is about 700 to 800 will be acceptable. Okay. If the question was, okay, now this was not on the question paper. If the question was to calculate Q1, your quartile 1, or even your interquartile range, the question was to calculate your interquartile range. Interquartile range. We know for the interquartile range is going to be Q3 minus Q1. Okay. When I ask you the semi-interquartile range, is Q3 minus Q1 over 2. Okay. So for your interquartile range, I take my Q2, which is my median, which is 13.5, and I further divide that by 2. Okay. So we get 13.5. 13.5 divided by 2 gives us 6,75. Okay. So I take my reading there at 6,75. So that's 6, 7, 8. So 6,75 is very close to 7. And you'll see it's a value very close to 700. So let's call that 700 occurs at 7. Yeah, that is why, as you can see, it's very, very close. So let's call that 690. Okay, let's go 690 on that one. And then Q3 will be 3 over 4 times the number, which is 27. That gives us 20,25. So we go again on the graph, 20,25. So it's 15, 18, 19, 20. 20,25, which is above 20. With my ruler, as you can see, I'm using, I'm not, but you should be using a ruler and you take a reading there. So this is your Q1, Q2, which is your median, and Q3 here, which comes to a value of 850. Or just above 850, let's go with 860. So Q3, Q3 is 860 minus 690 approximately. So that's going to give you 800 and what did we decide on? This is above 850. So let's go rather than 860. Did I say? I'm sure I said 860. I wrote down the wrong number there. So I go 860 minus 690. That gives us 170. So my interquartile range here is 170. Okay? If they ask you to draw a box and whisk on this, there's your box. Okay? There's, whoops, there's your box. And normally they tell you what is your minimum value and the maximum value. Let's say your minimum value was, what was our, I think our minimum value was 580 was our minimum value on the raw score. So that is 550. So 580 is approximately here. It's 580. This is 690. This is your median was 780. Quartile 3 is 860. And your maximum value came in at 970. So 950, 60, 70 is approximately 970. If they'd asked you to draw a box and whisker, which they did not, okay? They'd ask you about the skewedness of the starter, Okay, again, that the question wasn't asked. Okay, I'm just doing variations on this question. I'm sure there's many more, but just things that's coming to mind here. If I look at this gap here, okay, 780 to 580 is 200 units. Okay, going from the 200 rand, sorry, from 970 to 79, so that is 190. So the dot is almost skewed, symmetrical, which means to say they're almost balanced. Okay, yeah, so it's very, very close to each other. So if you had said the data is symmetrical, you'll probably get them off. But by calculation, we can see the data is actually skewed to the left. Okay, as you can see, the gap is a bit bigger on the left, or we can say negatively skewed. Both would have been accepted there. Okay. The next question, let me just get that quickly. Okay, so in question 1.5, they asked you to use the distribution table given. It's table 2 now. As I indicated, this is your distribution table. Alright. To calculate the mean cost of the electricity on a particular month for the residents of the block of flats. So to calculate your mean from a distribution table, we need to know what the class midpoints are. Okay? So to work out the class midpoint, we don't know if that one number is laying at 500 or 600, provided we didn't have table 1. So what we do is we work out the average of the class input. How do we do that? We say 500 plus 600 divided by 2 is going to give you 550. Okay? The next one is going to be 600 plus 700 divided by 2 is 650, then 750, then 850, then 950. Okay? So this is what you call your class midpoints. Alright? These values are your class midpoints. And this is our frequency. So very importantly, we have 1 in that category, we got 6 in that category, and so on. So to calculate your mean, we could just say 550 times 1 plus 650 times 6 plus 750 times 8 plus 850 times 9 plus 950 times 3, and we divide everything by 27. Okay? That's how we get the mean. But if you look at the next question, is standard deviation. So if the following question is standard deviation, we might as well work out our mean from the calculator as well, because I will get both values at the same time. So to program your calculator to do that calculation, we do it as follows. We do it as follows. We need to get our frequency on, so we press shift, mode, the down arrow, 4 for stat, 1 for frequency on. Then we press mode again, as we normally do when we're working out standard deviation and mean. Press 3, and then your variance. Okay? Remember, your variance is going to be the standard deviation square root of variance. Okay? Alright, so the X column, the first column, you put in your class midpoint. So it's 550, 650, 750, 850, 950. Okay? The corresponding frequencies for the first category was 1, second category was 6, 750 was 8, 850 was 9, 950 came in at 3. Is equal. So all our data is entered into the calculator now. So what do we do now? We store the data by pressing AC. Then we press shift 1, as you can see in yellow there. To activate any yellow key, I press shift first. Any maroon or red, whatever key you want to press, you press the alpha with the button next to the shift. So you shift 1 to activate your stat mode. 4 for variance. Number 1 is the number of units that you entered, or the number of the sum of the frequencies, which is 27 if I have to press 1, but 2 is what I'm looking for, which is your mean. So the mean comes in at a value of, the mean is 775,93. Okay, so that is your mean for that data there. Then now standard deviation, we press shift 1 for stat, 4 for variance, 3 for standard deviation. Press equal to, gives me 103,9697, just standard deviation. Okay, that tells you that, okay, standard deviation tells you how far or how close the data is to each other. Okay, or how far the data is deviating from the mean. It's moving away from the mean value. Okay. So in question 5.3, we are now told hence. So hence you must use the previous calculation. Okay. Hence using the raw score or the raw data, which is table 1. Determine the percentage of households. So to calculate the percentage, you must divide it by the total number, which is 27 times 100 of households' electricity charges for this particular month, which lies within one standard deviation of the mean. So we need to set up a range here. Okay, so what we do is we say our mean plus your standard deviation, and your mean minus your standard deviation. Okay, we're setting up a range here. So we go on the calculator again. Your mean, which is 775.93 minus 103.97. That gives us 671,96. Then of course the positive one is 879.9. So this is the range in which the values must lie between. Okay, this is a common ask question. You must get this right. Okay, so we count all the values between that. Okay, so I'm not going to waste much time. I've ticked it before already. So we count all these values that are ticked is lying between those values. Okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 values lies between, okay, I've ticked one too many. Okay, because according to what I've ticked earlier on, I got 20. Just count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 20. So one of these values, I think it's 970. 970 shouldn't be ticked. Let me just check here. Yeah, 970 shouldn't be ticked. Okay, that one mustn't come in there. So it gives you 20 values. Okay, sorry about that again. So we get 20. So it's there for 20 out of 27 times 100. Why am I multiplying it by 100? Because I want the percentage. So I say 20 out of 27 times 100 gives me 74.07%. 74.07%. Okay. So that is question 1. Okay. Okay. Okay, so if I've made any errors, please, you can let me know on that number there. Okay, so in question 2, we are told that the table alongside shows the marks for mathematics and English with a random sample of 10 matric learners. Okay, in question 2.1, we are asked to calculate the correlation coefficient, which is the R value, to 3 decimal places and comment on what it tells us about the relationship between the performance in English and mathematics. So to program a calculator there, again we press mode, so stat, so it's 3, 2, which is a plus bx. Okay, we don't need the frequency on. So if you want to put it off, you may, but in this case, the frequency will just come in as 1, 1, 1, 1, 1. Okay, if you don't have a frequency now, don't worry about that. So the first entry is 54, then 54, then 64, then 62, then 70, then 70, then 72, then 80, then 78, and then 83. Okay, so we just in the second column we got 43, 46, 64 with 50, then 71, then 72, then 76, then 77, then 82, then 87, then 91. Okay, so what we do thereafter, we press AC, we're going to store the data, then we press shift 1 again, and then we're pressing 5 for the regression line, 1 for A equals, gives you negative 38,44. So you've got y is equal to, remember it's going to be a plus bx. So y is equal to negative 38,44. So it's 38,44 plus, I think it should be plus in this case. So you press shift 1, 5, sorry, wrong. I'm supposed to have got an R, that's your correlation coefficient. So it's 5, 3. Normally we ask correlation coefficient afterwards, but in this question it was first. So the 0,92829. Okay, as the question says, to 3 decimal places. Okay, so what can we say about this data? If you look at this table, I took it out of a textbook that is currently used. Generally, they describe your correlation coefficient or the relationship between the data as follows. So if you've got negative there, 0, and positive 1 there. So if it's negative 1, it's perfect positive correlation. If it's negative 1, it's negative perfect correlation. Okay, so if it's on the negative side, it's negative. So the positive side is positive. So 0, for 0, is having no correlation. Correlation means the relationship. There's no relationship between the data. Okay, at negative 0,5 or 0,5, this is moderate. Okay, so this would be a negative moderate, that would be positive moderate. Okay, so anything between, so they mark off at negative 0,8 and 0,8 there, this is strong. Okay, anything between 0,8 and 0,5, this is moderately strong, so it's moderately strong there, and then this of course is going to be weak here. So negative weak, positive weak. This is moderately strong, this is the strong and positive. So if you look at 0,929, that puts you in this category here. So what we expected you to have said, it is strong positive correlation. Okay. Then in question 2.2, determine the equation of the least squares regression line. Remember that is in the form of y equals a plus bx. Okay, so we already entered our data, so we press shift 1, 5 for regression. 1 gives us negative 38,44 plus the b value. Shift 1, 5 for regression 2 gives us 1,57. 1,571, so that is that. Okay. Then in 2.3 we are told predict the mathematics mark to the nearest whole number. This explicitly says whole number, so if you don't put it in whole number, you can compromise your mark there. The English is 30%. Remember your English was x there, so it's negative 38,44 plus 1,57 times 30. Put that in the calculator. So you get negative 38.44 plus 1.57 times 30. So it's 8.66, which gives you approximately 9%. Now some learners, they made a mistake here by putting the x here. They put the x there, and because normally in a straight line we have y is equal to mx plus c, so they put it as ax plus b. People, that is wrong there. Okay. Also, if you're sitting in your final exam, do this calculation twice. The reason for that is because if your r value is wrong, a value will be wrong and your b value will be wrong, and that is, there's no CA marks for that. Okay, that is precision marks. You must get that value correct. And then in question 2.4, they say comment on the reliability of prediction in question 3.2, which is this one here. Okay, so is this reliable data? The answer should be no. The reason for that is because if you look at the data itself, 30%, none of these learners, the lowest value here was 54, and the maximum value was 83. So if you're looking at where does 30% lie, 30% lies here on the outside part of the data. So is this reliable? No. The reason for that is because this is an extrapolation of this data. Or we can say that this number lies on the outside of the data set. It's not within the data range here. Can you see that? This is for English. This is coming from here. For English, it's lying outside the data range. Therefore, it is not a reliable calculation to depend on. Okay, I hope that makes sense to you guys. Okay.